Waiting to see the live stream has started. Cool. And I think we're live. Hey everyone. Welcome to today's developer-ish session. About 3 weeks ago, we had a session on System Design 101 that was hosted by Harith, and feel free to check it out on YouTube if you haven't already or you missed it. I'm going to be the moderator of today's session on Open Telemetry. My name is Chris, or Big Zoo. Welcome to yet another developer session. If it's your first time, definitely check out our YouTube channel where there are a bunch of previous sessions, and this one will be added to the YouTube channel as well. So today's session is going to be done by the one and only Georgine, and is going to be focused on open telemetry in practice. If you are especially a telemetry interested person, if you work in distributed infrastructure or not, this is definitely going to be an interesting one for everyone. Please feel free to use the chat for any questions that you may have ongoing. We will have a Q&A after the end of the presentation. So we will go through questions on chat, and we will also have room for guys asking questions. You can post your questions on the YouTube chat or on the call if you are on the call, or anywhere else that you may have access to me. I'll check my Twitter as well. So without further ado, Georgian, take it over.
Okay, thanks, Chris, for that awesome introduction. I'm Joe Green. I'm going to be taking you through OpenTelemetry and how to use it. By the end of this call, I hope you go and check out the project and start playing around with it. So I will just go ahead and switch to the agenda. And my goal with this is to cover, if you want to do OpenTelemetry, OpenTelemetry is a tool. So the question becomes, what does it help us do? So in our agenda, we'll have to discuss what is observability, and then figure out how does OpenTelemetry relate to observability, and then get into some concepts you need to understand to use OpenTelemetry. I'm against using slides. Slides are boring. So ask questions so that this is more interesting. We don't have to go through the entire slides. As long as the concept is understood, I think that's a win. And if we have some time, we can go through a demo. This demo will be on .NET, but that doesn't limit the tool to .NET only. You can use this tool in any other language. Or if it's not in your language, there is a specification and you can try to implement the tool in your language. So that will be it. I need to say that I'm a Microsoft employee, but the thoughts today, I present my own thoughts, and this do not represent thoughts of my employer in any way. So again, this is my own thoughts, and I take full responsibility of that. So observability basics. What the heck is observability? I think I would have asked this question if it was in person, but we need to understand what observability means and why we need it, right? And the term observability in itself was coined earlier, I think in around 1960s. And the person who coined this was using this in a mathematical sense. They're trying to understand what exactly it means to have a system that is fully observable without really having to open it up. The guy who coined this was an engineer called Rudolf Kalman in 1960, and he basically used this in a mathematical sense. And over time, this idea has been used in software, has also been applied in software. And how it has been applied in software is we want to understand the inner working of our application by interrogating its external outputs. We just want to look at the external outputs of our software and understand what's going on. Sometimes we also want to understand any application state by just looking at its output. Like we want to answer the question of what is the state of my application right now, given this is the output it's giving me currently. And this should be done without shipping new code there. So this is what makes a system observable. If you can understand your system without adding any new code, then you are on your way to being observable. The official terms, though, how people define observability is the ability to understand the internal state of your system from the outputs it gives you. If you take it as a noun, that is how you describe it. If you take it as a, let's say, what is this called? A descriptor. It's something that measures how well you can understand the knowledge, how well a system can be inferred from the knowledge of its external outputs. I don't know if that makes sense, but the idea is that you want to be able to poke or understand what is happening within this closed black box without really opening the black box. And this sits well in software because once you ship software to production, essentially you have a black box now, and you have to understand this black box. Okay, moving on. So I think I haven't answered the question of why observability. You need observability because as you build software, you'll quickly come to understand that there is functional requirements to your software. These are things your software has to do, most likely requested by your customer. And that is non-functional things which you have to do to make the software run smoothly and provide a real service. So observability falls in this category of non-functional requirements, whereby once you build your awesome piece of software, to make sure it continuously runs, you need to find a way to incorporate observability in it. This will enable you to quickly resolve bugs. It will enable you to gather some statistics about what's happening on your system. It will enable you to be able to apply resources effectively on your application. You need to know how many people are using your application. That tells you if you need to scale up or scale down. So that's why you need observability. It's essentially a non-requirement, non-functional requirement that makes it easy to run your application. So I think I've answered what is observability. Again, it's this idea of you have a black box and you need to understand it by just looking at its output. So then the question becomes, how do we get this output? There are multiple ways you can look at this. You can just use the output only, or you can instrument your application to produce data that helps you understand your systems. Most of the time, how this is done currently, you just put in logs, and that becomes there's this output your user receives, but there's this other output you receive as a developer, and you usually go through it, and these logs can help you sometimes understand what's going on in your application. So once you instrument your code and you're producing the data, then the next thing you have to do in case something goes wrong, you have to query that data to answer some questions, especially if you have multiple instances of your application running. Sometimes you need to find out which instance of your application is causing the issue. That means you have a corpus of logs and you have to filter down or query down to the logs that have issues. So yeah, so in observability, you have these two ideas of you instrument the data, and then on the other side, you're there trying to query this data to answer your questions. Okay, so looking at this, we have said you need outputs to make your application observable. And this is where we get to the idea of telemetry. This idea is that, okay, not only are you giving your end user the output they need, your software needs to output other things to help you understand what's going on. These other things you output to help you understand what's going on is telemetry. And telemetry in itself, just producing data does not make your system observable. It's that telemetry helps you to make your system observable. So even if you can have systems that have outputs, but those systems are not observable if those outputs are not helping you understand what's going on underneath. So what examples of telemetry? I think you guys have seen this. I won't bog you down with this, but I think all of you have seen metrics, which is just an aggregated summary statistic. What that means, it's one number that can tell you, that can summarize an entire application. So for example, if you want to know how many requests am I serving now, you just get one number that tells you your application is serving 10 requests right now, or a billion requests if you're lucky. And then logs give you the answer questions of, I have a aggregate summary that says I have 10, I usually get 10 users, active users, but all of a sudden my users have dipped to, let's say, 5 users. You can usually look in your logs to find out why that's the case. So you can see that you usually have this flow of, you look at a metric, the metric has either gone up or down, and that way you dive deep now into logs to figure out why that metric went up or down. In some other system also, if you are running a complex system, complex means you have more than one instance that have to call each other. Sometimes you use distributed tracing. I know it's an interesting one, but that most of us currently what we do is you have this request ID on your logs, and you are able to track these request IDs between services. So you can have this correlation of log A was generated in the same request as log B. So that's basically what distributed tracing is, or how people implement it currently. This idea of just finding a way to stitch logs together that come from the same service. And as you can see, these things, most of them, you're doing them currently. So OpenTelemetry is just another way to do this. And I'll talk about that. So given that we know the data structures we need to produce, and so that to make our systems observable, there are two schools of thought on this. There's this idea of traditional observability. Sometimes people call it monitoring. But in this, this school of thought claims that for you to be able to make your system observable, if you just produce logs, metrics, and traces, this is enough to make your system observable. One thing to note about traditional observability or monitoring is that these data structures or this telemetry is usually produced as separate entities. So you produce your logs, you put them somewhere different. You produce your metrics, you put them somewhere different. And then the logs you have are usually stitched together using a request ID or a correlation ID. And this is how you get tracing in this traditional observability. This might be the thing most people are doing right now. It's a very popular concept. If you have heard of the 3 pillars of observability, they stem from this idea. I think Google are the one, there's a book out there that Google seemed to praise this idea of, if you have these 3 things, then you are observable. And but this idea has problems. The problem is this, the challenge with traditional observability or monitoring is, if something happens, if a user gets an error, the question becomes, can you recreate, can you put your telemetry in a sequence to show you exactly what kind of correlation led to this error? So usually find you have so many logs, and now you have to use something like grep, or if you're using Azure, you have to use something like Kusto, or I think if you're using New Relic, there's a way you can query their logs. So the problem is that given that your logs are produced as separate entities, when something happens, you have to invest some time into building back those data structures into a single request so that you can follow it and then be like, okay, so this is what happened. The issue with this technique is that you spend a lot of time just gathering the data you need to solve a problem. So most of the time is spent gathering the data rather than solving the problem. Okay, so then the next school of thought is modern observability. I think this is what everyone is calling it. I don't know a better name. But in modern observability, the emphasis is that the data structures you emit from your application, or the telemetry you emit from your application, should combine all of these 3 things into one thing. And this one thing is usually called an event, and this event should be able to describe your entire request. So an event should be something that has a timestamp and a bunch of attributes. So in this new school of thought, the idea is that what you need to do is you need to generate one event that captures three kinds of attributes. And these attributes are, you need to capture operational attributes. These are usually specific to that request. Things like account ID, user ID, they're usually very specific to that request. And then you need also to capture resource attributes on this event. And resource attributes are usually which server is this thing running on, which region is this thing, is this request executed on. And then finally, you need to capture causality attributes. And causality attributes are usually what put these events into a graph. So you say that event A occurred after event B. So what that means is that event B will have a reference to event A. You'll have something like a parent ID, and then that is event A. So in modern observability, if you are able to produce a data structure called an event that has these three things, they claim that this will save you a lot of time when you are trying to find out what happened, because instead of trying to collect all the data that happened in a request, if you store your telemetry in this manner, all of this data is usually in one place already. And when you try to retrieve it, all you have to do is pull it out and start thinking about the problem, rather than trying to, first of all, fetch the data, try to put the data into a format that you can understand, then finally start solving your problem. So modern observability comes in to help you with putting the correlation back into requests. Put everything that happens in a request in one event, and that makes it easier. Okay, so there are other concepts in modern observability. There are things like tracing, and tracing usually means you have a causality whereby event A was caused by event B, and then event B caused event C. These events are usually captured with things called spans, which represents a unit of work. And then a collection of spans make up a trace. So a trace is an explicit thing. It's not really implicit. You won't say it. But if you have a group of related spans, those become a trace. And the good thing about tracing is that if you have more than one instance of an application running, the issue becomes that something that happens, if there is a causality relationship between service A and service B, all the context that was in service A does not have a way to be propagated into service B. But when you have tracing, there's a mechanism to get the context from service A and you deliver it into service B, so that when you're generating your telemetry is aware in which context is it being executed. So this is this idea of distributed tracing. And we will see this in a demo where this becomes a reality. So there are more things you can add to traces. You can add events. I won't go into that, but usually this means you can add some custom things that happen. You can add exceptions. You can add logs inside there. And also, I think I've touched on this context propagation. This idea that if you have a request happening in a web server, if you call, let's say, a database, the database should be able to understand that the request came from a HTTP server, and this is exactly what had occurred before it was called. That way, it can generate telemetry fitting in that context. So context propagation is this idea of how can we take the request context and pass it into different systems. Oh, there are different standards, by the way. I think this is important to mention, but the de facto one that has been adopted by a lot of people is this W3C context trace. Okay, I was trying to rush through that because it was not that important, but we had to go through it either way. The question now becomes, how do we implement these ideas of traditional observability and modern observability? And this is where OpenTelemetry comes in. So you need an instrumentation framework. You need a place to send the data. I was trying to rush through that because it was not that important, but we had to go through it either way. The question now becomes, how do we implement these ideas of traditional... Howie, can you mute? Thank you. So how do we implement these ideas? So the next, this is where we need an instrumentation framework. We need a place to send the data, and then finally we need a way to visualize this data. So this is just describing a typical application. You usually have your application, you usually have some agent that is running alongside with the application. This agent collects this telemetry and then sends it to some downstream service that can show you what's happening. So how can we do this now? And this is where OpenTelemetry comes in. Okay. Yes, this is where OpenTelemetry comes in. So this is the core of this talk, and I'm happy to show you what this is. So we begin with some historical context. What is OpenTelemetry and where did it come from? So OpenTelemetry is an open source project, and the origins is that there are two projects. I think they were started around 2015, and these two projects are OpenTracing and OpenSensors merged, and then they formed OpenTelemetry. And how we describe OpenTelemetry is essentially, give me a second, something is not working. Okay, here we are working again. So OpenTelemetry is it's a project, and the goal of this project is to provide a single set of APIs, SDKs, and libraries and agents to capture metrics and distributed traces from application. So essentially, it's just a observability framework. It's a framework that will assist you to make your applications observable. It's intended to be a whole solution out of the box. You don't have to do much apart from just importing it into a project, and everything should just work. Okay, so this is the big picture of how the project is implemented. We have three layers. There's an API layer, SDK layer, and then there's this vendor layer. We are developers, so most of us will be concentrating in the API layer. And in the API layer, the primary concern of this is instrumentation concern. So instrumentation just means how do you set up your application so that it generates telemetry. How that telemetry is represented, how that telemetry is shared between different systems is done within an SDK. And this SDK is usually implemented for every language. And most likely, unless you're a library author or you want to contribute to this SDK, you won't be here. So it usually, this is the SDK layer, as you can see, it usually handles application or operational concerns. So it usually handles the idea of, okay, if if an application wants a metric, how do we implement that data structure? And this side on the end, this is where your vendors exist. I'm not sure what other people use, but this is usually New Relic. I think there's something called Azure Apps Insights. So this is where you send your data when you're done. On your local machine, this is just your terminal, maybe your file, or maybe if you can run a local instance of something like Zipkin or Jigger. And also they have this OpenTelemetry collector, which is an initiative to try to unify how you collect, you export metrics from your application. As I said earlier, most people run an agent on their application, and then this agent sends this telemetry that your application has produced to a third-party service. So OpenTelemetry collector is an initiative to make just one collector to rule them all, and there are benefits that we can talk about later. Okay, there's some important pieces inside here. I would like to go through them, but I will let the questions come in if there's something I need to talk about inside here. I can usually go into it. Okay, so as I said, there are multiple languages that implement OpenTelemetry. Today, we are going to be using C#, but all other languages also implement this. There is Go, JavaScript, Java, and Python. Especially for JavaScript, this is a good idea. So if your backend is, let's say, in Python and your front end is in JavaScript, React, it means you can see telemetry from your front end to your backend as one thing. And this is such a good idea to have. Okay, so this is just how OpenTelemetry is packaged up. There are two concepts inside there. There's this thing called a tracer and a meter, and that's all you need. A tracer is just responsible for capturing all the operation happening in your application. And these operations, we call them spans. A meter is just responsible for capturing all the aggregates that are happening in your application, and these people call them metrics. So a tracer will generate all your spans, and a meter will generate all your metrics. This is not that important, but we can skip. I think I've talked about it. I can show you what an exporter is. It's not easy to explain, but just looking at it. And I've also talked about the connector. So I'm going to skip this. Finally, the vendors. Where do you send your metrics? I think I've said Jaeger, this Prometheus, I think this Grafana. If you're working on local, which we are going to be, you just send your stuff to standard out so that you can see that stuff. And standard out can be anything, can be a terminal, can be a file, can be a socket, whatever you want. Okay, and that will be it. Let's quickly jump into an interactive demo and let's see what these concepts look like. I'm going to pause for a little bit to just ask if there is a question as I switch to this. Okay, I think I'm ready. Let me see if this thing is running. Yes, it's running. Yep. Okay, so everything seems to still be running, and that's good. So we have this application here, and we are going to just do a bunch of requests and look at the telemetry, and let's see what we can discover from the telemetry. And then from that, we can come back here and just explain what the heck is going on. So I have two services. A service called Catalog Service. I think this service is inspired by, there's this course on, I think, Udemy and YouTube, created by some individual that I followed, and they just took whatever they built and added in telemetry. So a catalog is basically a service that lists out the different things you have. Essentially, it's just a catalog. So things we can do things like, let's try this out. We can create an item. So we can create something like magic potion, and you can just say the description of this is just magic within our catalog, and we're going to say the price of this is like 100. So if you have played games like Minecraft, I think you'll know what this is. I usually have this catalog of things you can have, and they're usually things like magic potions, spades, and all that. So I'm going to try to execute this, and let's see. Yep, and you can see that there's a response here, 100 bob, or whatever that is. There's an ID and there's a creation date. And we can also do things like, what else do I have to want in? I think I would want some wings to be able to fly, and the description would be fly. I think flying is expensive, so maybe 1,000 would be good for that. And then I execute that. And now we have two things in our catalog, and we can just get all of them. Let's try that out and execute. And you can see we have these two things in our catalog, magic potion and wings. So that's it. The inventory service is that once you have a catalog, people will want to own this thing. So an inventory service just gives you a capability of owning this stuff. So for example, like let's see what we can do here. Let's try to create an inventory. So yeah, let's try this out. And we have this user ID. I'm just going to keep that. And then we're going to say this user will own, let's say, a magic potion. The ID, we can, so we can just get the ID of the item in the catalog. And we can just say, okay, this guy owns 10 of these things. So think of this like a player in a game who has been able to redeem 10 magic potions. And that's it. And you can see we have some stuff here. Then what we can try to do is, let's see if we can get everything that this user has. So we can try this out. And we execute this. And, oh, wait a minute. Something happened. Okay, this is bad. Well, this is where you need telemetry when such things happen. We can jump into which is our vendor in the picture I showed earlier. This is where our telemetry is sent, and we can try to figure out what the heck went wrong there. So we can reload this, and you guys can see it says I have 3 services, and then we don't know what this application is, so we can try to figure out what's going on here, and we can create the system architecture, and we can see we have 2 services, and there's this thing called an inventory service that somehow is able to call into the catalog service, and it seems to have done this twice. So even without looking at our code, we're starting to get an understanding what exactly our services look like. And this is the whole idea behind this observability movement. So let's look at inventory. It's the one that failed. So let's find all traces and see what's going on. So we can see that inventory.service made a request. It got 2 errors, and yeah, it made a request to catalog service. So we can click into this to see what went down. I'm going to increase the size of this. I'm not sure if this is visible. But as you can see here, we see there's this operation that happened, aka a span. There's this span that shows us that we can look at the attributes that this span has. We can see it has some context tags, things that describe this operation. This operation happened on localhost. It was a get. And okay, even the route, and we can see we had a 500 here, and some other interesting stuff too. Oh, we can see that there's an error here, and we can see there's a description of oh, this circuit is open now. Okay, that's interesting. And we can see that we made a call to this. This is the controller, and then this controller made a call into a function called getAsync. So let's look at this. It says success true, should be, but and then this function seems to have made a get HTTP get call, and it seems that is where things went wrong. You can see we made a call from inventory service to catalog service, and we can see that yes, and now we can see that from our function we made a call to a downstream service called this, and we can see that it failed because of this. So as you have seen that flow where we capture all the telemetry in one event called a span, and we are able to capture all the events or all the spans that happened in that operation. Debugging becomes a little bit easy because all you have to do is follow through that operation, and you don't really have to look for the data. You just have to think of the problem you are, try to find the root cause of the issue you're having. And for us, I think we can conclusively see our root issue seems to be something to do with SSL, because this is the deepest part of the application. If we had other stuff, imagine if we started from here, you see that the error that we get here is something to do with the circuit. So being able to infer that this circuit error was caused with something to do with the SSL won't have been as easy if all of this data wasn't together. So yeah, that is an example of a trace and how it looks. We can also look at, we made some calls to catalog service. So if I do this and find all traces, we can see that it says, oh, it has the same trace. It says there's this service called inventory that called it and it failed. But you can see that all the activities that we did on catalog alone were successful. When we created those 2 catalog items, you can see it says we got here from a HTTP. And then here we can see it's some sort of method call, and yeah, it's an internal thing, and it was successful. So, okay, this looks good. Okay, so this is an example of generating events or traces. And this is an example of, Jaeger is an example of a backend service or vendor that you can send your traces to, and they can help you visualize and make it easier to find events or traces that have problems. You can clearly see all the events that have, all the traces that have problems, and everything related to that is in one place, and you don't have to dig around in a query language or something to find what's up. Okay, another thing I talked about is metrics. So here I have Prometheus running, and if I reload it, let's see if we'll see anything here interesting. Yeah, you can see we have some HTTP client duration buckets, some very interesting, weird looking labels. But as you can see, if I secure this, you can see we have multiple metrics generated, and these metrics include some context, some attributes like HTTP code and all that. And you can use a tool like Grafana to visualize this in a more beautiful manner than this. And this usually helps you to, as I said earlier, metrics are what trigger you or what you build alerts on top of so that they can tell you, okay, something has happened. And when this something happens, let's say the metric goes up or goes down, you need now to jump into your logs or traces to figure out what's going on. So I'm going to show exactly how I was able to make the two services do this in code. And I don't know if there's any questions, so please feel free to shoot some questions if you have some. If you're not a C# developer, I'm very sorry, but it's not that, it's basically Java or C. They look very similar. But the core idea is, I'm going to close this. The core idea is that we have those three data structures and we want to connect them. So you have to configure your application in such a way that it can get this data. So to get logs from OpenTelemetry, all you need is to download the OpenTelemetry SDK, add it to your application, import it, and this is all you have to do. So some of these are just fancy ways to make sure I capture everything, but essentially all I do is say, we're using the builder pattern here, as you can see. All I have to say is that add an exporter, and this exporter, which is a service that can receive telemetry, is on this URL. As easy as that. I don't know if you have ever tried to add other SDKs into your application, but I would say this is one of the easiest, in my opinion. So this is how you add logs. It's a simple one-liner, and you don't have to do a lot to get logs from your application. Other things we saw metrics and telemetry. So similar concept. To add metrics, which kind of metrics do you need? Yeah, you usually need latency and reliability. And from OpenTelemetry, there's this idea of automatic instrumentation, where for every framework that exists, there's usually one library that can just be downloaded and added to your application, and that way you automatically get latency and reliability. It's not that doing these things is difficult, you can do them on your own, but when you use automatic instrumentation, you get this consistent between different services, because everyone is using services. So the idea here is that you want to be able to understand telemetry from different services without working on those services. So if you imagine yourself working in an organization where there are multiple services, one problem is usually that when you go to look at their metrics, they look very different from your metrics. But if you use things like automatic instrumentation and everybody sticks to that pattern, it means that we have this consistent view of telemetry between different services, and it becomes very easy to understand what's going on, especially if you're consuming that service. So whenever something goes wrong, you can just open their dashboard and see what's up with almost zero explanation. And that is usually a win if you don't have to talk to a lot of people just to figure out what's going on. You're trying to solve the problem. You're not really trying to talk to a lot of people. Okay, so this is how you do instrumentation with OpenTelemetry. As you can see, it's a one-liner, or not really one-liner, okay, a bunch of lines. But the idea is that it happens in one place and you're done. Same for adding traces, same idea. You give it some resources. Resources just where is this application running? So you give it things like names. Here's where you can put in data about regions, instance size, anything to do with that resource can be put here. And then again, same idea, there's automatic instrumentation, so you don't have to do it on your own. And then finally, after you capture those traces, you need to send them somewhere to a downstream service. And this is how you do it. You just say, point me to some URL or some collector that is running somewhere, which takes us away from this idea of having to run an agent on the same machine. This is very uniform. The API is very uniform between different languages. So even if you're going to use Python or if you're going to use Go, these same ideas apply. They try to make sure the API is standardized so that even if you're not the same language, maybe the camel case might change, but the same wording will be used. So yeah, I'll share a link on how to do this in other languages so that if this is not your language of choice, you can do that. So this is just one service and that's it. That's all you need to do. And another service I have is inventory, and it's basically the same. If you can see here is this is how I capture my logs. And if I go to startup, same idea. This is how I capture my metrics. And this is how I capture my traces. So same idea. So if you're running a service, this is how you do it. This is how you capture telemetry. And if you're not running a service, but let's say you are providing a library. So for example, this is a library that is used both in catalog and inventory. This library is for accessing MongoDB. So if I open it quickly, you can see it's just a bunch of functions that have a MongoDB client, and then they just send those queries down to MongoDB. So if you're a library author and you want to make your library observable, one of the technique you can use is this decorator technique, whereby you just write your code as is without the telemetry, and then you write another class that usually just takes the core thing you need and wraps it around telemetry. So for example, here you can see I depend on this repository, and around it, I don't do anything fancy. I just send the queries down to the implementation. But here is where I add those telemetry concerns. And this is how you do it this is how you make your library observable, in the sense that anybody who's using your application can opt into, instead of using this repository, they can use this repository with telemetry. And this way, every call that is made to this library generates this telemetry that's then sent to a downstream service. So you can see this is not API or anything, but all you have to do is wrap it around these spans or activities, as they're called in .NET. So you create a new activity, you carry out your operation, and then based on this operation, you can add some tags or attributes to that activity. I just added success true, but you can be a little bit more creative. You can put some try catch around here, and you can collect whatever attributes you need. And that will be it for libraries. Actually, you don't even, in .NET, you don't even need to install OpenTelemetry to instrument a library, as you can see. And that's it. I will pause there to get some questions and get some feedback, because I think there's a lot of stuff to be talked about, but it's good if I can hear what's going on. Oh, there is some chat. It says you classified modern attributes as causality, resource, and what was the third type? Oh yeah, so causality, resource, and then operational. Causality are things that help you stick the events together. They're the ones that form a graph of event A happened, then event B happened. So if you go back to Jaeger, if you collect those causality, if you're collecting, so let's use this as an example. If you're collecting these causality attributes, this is what enables Jaeger to build this view for us, because we say this happened, then this happened, then this happened, then this happened, then this happened. So those are the causality attributes you have to put on your event, so that a third-party tool can generate these views for you. So that's the causality. And then resource are, we want to figure out where did this thing happen, because you might have multiple services running in different regions, even running in different providers. Maybe you're running something in AWS, something else is running in GCP. You want to figure out where this thing is running. So those are what we call resource. And they're usually fairly static. They don't change. So you usually put them in somewhere once in a config and just use that for every service running in that region. And then the operational ones are things like this, things like route. Every request has a different route. It might be a get, or it might be a post. The status code for every service is different. Something might be 500, 200. So operational are things that change per request. So you usually want to capture those because those ones are usually relevant because essentially they describe the status of that relationship when it's, they describe the status of that event when it's done. So that's why you need those. And I think you can see the use case for those three attributes. They help you with different things. These operational attributes are the ones that will help you to figure out if something went wrong. Operational attributes also include things like latency. How long did this request take? As you can see here, I don't think I'd shown you guys this, but you can see this thing shows us a timeline. It says from 0, I think this is nanoseconds. This thing took around 2.1 seconds. And for every operation, we are shown how long it took. So you can see this is another operational thing that you might need, and it's very important, especially when things go wrong. So you can see here it took this one took 1.3 milliseconds, this took 4.7, this took, I don't know, 321 nanoseconds. But imagine you're trying to optimize this service. You can clearly see the huge places you need to, I think you might need to invest some time here. And okay. And I think there's something happened somewhere here you need also to investigate because this is almost half of the time was spent here. So those are some of the operational attributes you carry along. And then how could you explain instrumentation again? I did not quite understand that fully. So instrumentation is how do you add, let's say, logs or traces to your code? Most of the time, most of us do something like, let me just get a controller here quickly. Most of us do something of this sort. So in .NET, you usually say, I need a logger here, maybe a logger of type. I think you do it this way. So most of us do it this way. And then after you do it this way, let's say this is when you get, no, then I would most likely need to do something like this. Logger is equals to this logger I just got here. And then I need also to, because most likely this won't work, but I hope it demonstrates the idea. Yeah, C#. Okay, that way. And then most likely we do things like this .logger, and you say things like debug, I think, or info, I think, right? And then you put in some stuff. So this is what is instrumentation. Instrumentation is adding code, adding code into your existing application so that it generates telemetry. And this is manual instrumentation. You see, we have had to come in here and do this manually, but OpenTelemetry steers away from this idea. It says you should prefer automatic instrumentation over manual instrumentation. Automatic instrumentation just avoids this idea of littering logs everywhere. So automatic instrumentation does it once for you. For example, here, you can see this is add instrumentation, and that's it. I don't see it anywhere in my code. It's just done somewhere because it's a cross-cutting concern. I hope I've answered that. And then, good stuff, how does this compare with something like Sentry? Sentry is a vendor. So Sentry would be, I don't think we can run Sentry locally on my machine, but you can see Jaeger is also a vendor, but I can run, they have a Docker container that I can run on my machine. So Sentry and Jaeger are the same class. So let me just try to go back. In this diagram I showed earlier, Sentry would be here. It's a vendor. It's something that takes your log and does something to it. So Sentry will fit in here. And then as you have demoed, OpenTelemetry is not using a client for the logs, but posts logs to an API. Does this has an effect on the application latency? Yes, that's a good question, Sylvan. Yes, so there are multiple ways to get your logs or you get your telemetry out of your application. So right now, the one I'm using is OpenTelemetry Collector, but you can use any other that implements the OpenTelemetry protocol. So there are multiple. You can actually, I think there are ways to put in jig automatically here, zipking automatically, but I usually use OpenTelemetry Collector because it's agnostic. It allows me to hook it in once and then configure any backend I want. But if I put in the backend directly, then if I want another backend, I have to go in and remove it first. So I'm using OpenTelemetry, but essentially you can use whatever backend you need for those needs. For example, if you have a problem with latency, and OpenTelemetry Collector is using a lot of, you can swap it out. But the good thing about OpenTelemetry, it's essentially Open Collector. If I look at my infra, this is it. The good thing is that this thing is a service. You don't even have to run it on the same machine as your application. So if you have these problems of contention, you can run this outside of your application. And as long as you are able to, the only thing you'll have to pay for is the latency on sending the things to OpenTelemetry or this collector, but you won't pay the price of CPU, whereby your application and the thing that is collecting telemetry are trying to fight over CPU time. So yeah, you can definitely, the OpenTelemetry collector might be a good idea to use here because you can totally decouple it from your application and run it somewhere else as its own service. Over the context or attributes in the log, yes, you have control. The one I showed, you have control in manual instrumentation. The one I showed here, play.common. So I have an example where I show here. This is manual instrumentation. As you can see, I create the activity manually, and then I add in tags the way I want. So if you don't want some tags to go out, you can usually just create another activity and put in whatever you want, or you can use advanced techniques. Some of these advanced techniques are called sampling. The idea is that in sampling, you can sample an entire span and figure out the attributes you want to keep and the attributes you want to take out. So yeah, you can definitely do that. Okay. I think that's it. Yeah, so a lot of questions on OpenTelemetry Collector. It's a third-party service. If I can just go quickly through it. It's an API. And this API, what it does, if you look at the configuration, it has this thing called a receiver section. So receiver just means where will the logs come from? And right now I'm saying my logs will come from OTLP and the protocol is gRPC. So it means my application will send logs or telemetry to it through this protocol. And then after it receives those logs, the question is, or that telemetry data is, where should it take it? So this is where the idea of exporters come in. And I say, whenever you get data, send it to Prometheus, sending it to our logging infrastructure, and also send it to something called Jigger, also send some of this stuff to a file. So the question where you asked, do we have control over the context? This is where you have this thing called a processor. And you can write your own processor that for every telemetry data that comes out of your application, you can add in here a processor that looks into that data and figures out the things it has to remove or the things it has to keep. And then finally, we have this service pipeline, and this service pipeline just says for traces, we will receive it from the receiver we showed up there, or TLP. You want to process it in batch. We don't want it to come, let's say, streaming. We want it to say, give us in every 10 minutes or 1 minute or 3 minutes. That's usually a good idea. And then after we get that telemetry, we say, okay, export it to Jigger and also the login infrastructure. So if I look at my terminal, there's some stuff on it. This is there's also a metric pipeline. Same, we receive metrics from this. We batch them, and then finally we send them out to the terminal. and then we send them to Prometheus. Same to logs, we receive them through this. We don't batch logs because logs, sometimes you want to look at them immediately. So we send them to the terminal, and then also we send them to a file. I didn't show you this file, but this file is somewhere here. And if I open this output folder, you can see inside my logs, if you can see, let me try to save this. Yeah, you can see there's a lot of, these are just logs, and they say exactly what's happening. Log record, it says something happened in my application, blah, 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 as you can see here. I hope that answers some of the questions around that. Okay, so that will be it. And let me see if I had anything else. I think I'll go there. And I hope this is enough to help you start out with OpenTelemetry. There is a lot to be explored here. This is just an introduction so that maybe I can have future demos. I would really wanted to show distributed tracing, but I don't think I'll do that today. But this is the homepage, OpenTelemetry, and you can see everything I've told you. Collection of tools, API and SDKs. You can look at the docs, and within the docs, there's a lot of good stuff. It shows you the documentation, and this is just a big picture of how this service, how this project works. This is your service. Your service will send out some logs through some protocol. We are assuming you're using OTV, Open Telemetry Protocol here. You can send them directly to the third-party service. This includes Sentry, New Relic. What is this other one called? Elasticsearch. You can send your stuff to Elasticsearch, or you can send them to the collector, the thing I just showed you, and then the collector would send them to different endpoints. So a time series database, this is Prometheus. A trace database, this is something like Jaeger, and so much more. So yeah. And also you can see that the OTL can receive telemetry from APIs, managed DBs. So this means your entire infrastructure can just send telemetry to this, and you can view it in one single point. So if you're running on Kubernetes, you can see all your CPU usage and all that just in one place. So yeah, that's it. I'll send this out. You can go through it, and just in case of anything, you can reach out. This is instrumentation for different languages. I showed you .NET, but I think a lot of people here would be interested in JavaScript, the React side, and also maybe Python. So yep, this is the project, and you can look out for it and check it out. That will be it, and thank you for listening.
Awesome, Georgine. Pretty awesome session. I think we have one last question that just actually came in from Raf, who was asking, can you use OTel with a monolith? Do you want to quickly answer that?
Yes. You can use OTel with monolith applications. Actually, yeah, if you're using a monolith application, essentially traditional observability is enough for you. You don't need this modern observability, but yes, OTel can just generate metrics and logs if you don't want traces.
Yes.
Yep.
Cool. Thank you for the very cool session. I'm a big fan of observability. I haven't worked directly with a lot of these tools, but can definitely vouch for folks working in distributed environments where you're using, you want to keep track of traces. I'd love for us to go over tracing at some point. Where I work, we use traces very heavily with Go services, and it has saved us a lot of time. So thank you for the questions, and actually thank you, Georgine, for just going through the questions as they were coming in through the chat. Thank you for everyone who joined us through the live stream, and looking forward to interact with you guys next time. Feel free to subscribe to the developerISH blog. The link is on our Twitter and on our YouTube. And feel free to ask any questions that you may have down the line after the session on YouTube or maybe even on Twitter. Thanks for everyone who was able to join us today, and that's the end of today's session.